In this video I'm going to show you everything you need to know about angles for functional skills level 2. So by the end of this session you should be able to answer this particular question. We'll revisit this later, but let's dive in and have a little look about angles. In terms of level 2 stuff, it's mainly just knowing how many degrees there are in a shape and how you can use that knowledge to identify different angles or missing angles, if you like. So all shapes have a total sum of degrees according to their internal angles. So triangles have got 180 degrees in them. It doesn't matter what shape your triangle is in as such, but it'll always have 180 degrees in. Squares, rectangles, other four-sided shapes such as a rhombus, which is like that. Sometimes, well, often it's called a parallelogram. It's a bit like a rectangle that's had too many beers and started falling over. But we also have trapeziums, or trapezoids, as I'm pretty sure it's what an American word, but essentially trapezes. They also have four sides. They will be 360 degrees. We've then got pentagons for 540, hexagons 720, circles 360. So the total sum of degrees within a shape increases by 108 degrees with each new side. That's essentially the way you can work it out. So, three-sided shape 180, four-sided shape we're going to add another 180 onto it, 360. Five sides we've added another 180 on. Six sides we've added another 180 degrees on, and so on and so on. That's the basic knowledge you need about shapes and how you can use that information to identify missing angles. So if we had a question which was, how big's that angle? Knowing that there's 720 altogether, you should be able to figure out what that one is. Hopefully that makes sense. So I did mention parallelograms and trapeziums, and you can see these have got 360 degrees in. Now with the parallelogram, it might have a question where it just gives you that one angle and say, what is angle B or angle A over here? Essentially, opposites match. In that instance, having the knowledge that there should be 360 altogether, if this one's 80, you may have the knowledge that the opposite one would be 80, diagonally opposite. But you should also think, well, half of the shape would have 180 in. So if this one's 80, that one must be 100, because then they'll all add up to 360 altogether. Trapezium, pretty much the same. If we chop it down the middle, we'll see it's the same as the parallelogram on the left. The right is the other side, it's just been flipped over. So now our tops match and the bottoms match in a trapezium. But it's the same principle. 180 should be on either side. And again, if it's asking you for that one when it gives you that, then you should know that one's going to be 100. Okay, let's have a look at this one then. So the group need to build a ramp between the hospital door and the gardens. The angle of the slope of the ramp must not be more than 5 degrees. This is a diagram of the ramp. So we can see here with this diagram, we've got this little square. So this little square indicates what we call a right angle, which is a 90-degree angle. So you'll find with squares and rectangles, all of their angles are right angles. Okay, they're 90 degrees. So that's what that square represents. So here we can look at the ramp and we can see, well, we've got an 86 degrees and we've got a 90 degrees. So whatever's left must be the angle of our slope. So if we think we've got 180, take off 90, leaves you with 90 left over. 90 minus the 86 leaves you with 4 degrees as our missing angle. And that's all there is to it, 4 degrees. So having that knowledge that there's 180 degrees in a triangle, recognizing that that one there is a right angle, you can figure it out, find that missing angle there. Same process works with these here. Have a go at these, see if you can figure these out. We've made it a little bit more difficult. We've got an irregular pentagon, so 5-sided shape. Have a go at these and let me know how you get on in the comments. Okay, so with the triangle then, we know there's 180 altogether. Okay, so if we take off 60, so take off that one from the 180, that leaves us with 120. take off the 70, so minus the 70, that would leave us with 50 left over for our missing angle there of 50 degrees. In terms of the pentagon then, if you can remember from what we spoke about earlier, every time you add a side on, so starting off from three-sided shapes, every time you add a side on, you need to add on another 180. So four-sided shape would be 360. So our five-sided shape, which we've got here, is going to be 540 degrees. Like so. I'm going to get a calculator up for this one. Okay, so we know there's 540 in total. So we can just take off the 140 to start off with. Nice easy one to take off. 400 left over. We've then got three 90-degree angles. So minus 90, minus 90, minus 90. Leaves us with 130 left over. So that's all there is to it. We took off those four angles from our 540 that we've got in the middle, and that left us with 130 degrees for that missing angle there. Okay, so next one, parallelogram. If you can remember, I did kind of mention these earlier. So half of your shape needs to have 180 degrees on, so 360 in total. Half of it will have 180 degrees. So if that's 110, the other one must be 70. And that's all there is to it. Easy as that. Okay, so that just brings us on to our final question. So Lottie reads that the best angle to launch the ball from for free throws is 50 degrees. Calculate the angles A, B, and C. I think there's a bit missing off the question here. I think it tells you which, you're supposed to say which ones are 50 degrees. So we'll have a little look. Let's see which ones are 50 degrees. So if we look at A, we can see that we've got a 90-degree angle. Okay, so if we look here, we've got this 90-degree angle. 40 degrees of that is there. So what's our throwing angle there? So just 90 minus 40 is 50. So that one is 50 degrees. With the next one, we're looking at a full line. So a full line has got 180 degrees in it. So if we're going around there, so 180 minus the 35 that we've got and minus the 65 gives us an 80-degree angle there. And with the bottom one, so we can see we can actually use a triangle method for this one. So we can see that C down the bottom there, we've got 180 in a triangle, minus 65, minus 65 again, leaves us with 50 for C. So we've actually got two there that are the correct answer for the 50 degrees throwing angle. That's it for this one. Hopefully you found that useful and you feel a bit more confident with angles. I'll see you on the next one.